Hello, everybody, and welcome to today's webinar presentation, How to Give Security and Compliance What They Want in One Sprint, brought to you by ALTR. I would like to introduce you to our presenter, Chris Struttmann. Chris attended Florida Institute of Technology College of Engineering and is a member of ALTR's founding team. Over the years, he has served ALTR as Chief Engineer, Director of Engineering, and Chief Architect. Previously, Chris worked in the milli and microsecond crazed world of high-frequency trading. This is where Chris learned the discipline of optimizing for business-critical factors like latency and resiliency.
Thank you. Hi, everyone. My name is Chris Struttmann. I am the founder and director of engineering of ALTR, co-founder, I should say. The title of my talk today is How to Give Security and Compliance What They Want All in One Sprint. So hopefully this will be an exciting and relevant topic for you. Before we begin, just a little bit kind of about myself. As I said, I'm the co-founder, and I am responsible for ALTR's engineering initiatives. I am the named inventor on 24 of our issued patent filings. Our intellectual property portfolio is something that's very near and dear to my heart. I write JavaScript, TypeScript, C#, and C++. And I read and review pretty much almost everything. I pride myself in my kind of computer science abilities. I just read absolutely everything. I did develop the original ALTR proprietary low latency blockchain before we hired a team of really smart engineers to kind of take it and run with it. I wrote the piece of our software that allows us to do what you're going to see today. So hopefully you guys enjoy it. Quick note. There's a picture of me on a jet ski. I was asked to put something Florida in here because I am in the Florida office where all of our engineers are. So that's my tribute to Florida. So a little bit on the agenda here. We want to talk about the security and compliance team impact on the SDLC, the new approach to data security and compliance. We're going to do a little walkthrough of an installation, discuss the timeline, the capability, and how you're delivering, how that capability translates into value for the stakeholders. We'll go over some key takeaways. There's some FAQs, which I know you guys are going to have. And then hopefully we'll be able to do a pretty good Q&A here towards the end. So security and compliance's impact on development. Enterprise or endpoint protection is no longer adequate for enterprise app security. And you can see this in the real world because the breaches continue to happen. You can't go a week without seeing one of these major breaches on Hacker News or Reddit or the Wall Street Journal. They're just omnipresent at this point. Most applications today, we feel, they don't have a concept of the data that they're accessing. You just write your query, or even you have a piece of software write the query for you, and the data just appears back from the database. It's just something that's not really thought about. And so we think that there's a clear and present need for the applications to be security aware. The biggest thing I think that impacts developers is the sacrifice to innovation. It's oftentimes that security and the business needs security, the business needs compliance, and the requirement to meet those needs really cuts into your time to innovate, to make your product better, or to make your stack better, or to make your enterprise better. And so there's a definite, very difficult to quantify, but very important cost to a lot of these things, and we would like to minimize those things. And we want to really secure your application without negatively impacting development or your innovation potential. 65% of developers feel that rush to release, the pressure, and it's pretty easy to figure out that will result in more vulnerabilities. We want to solve this problem. So there's really two parts to the ALTR solution. There's the ALTR DB, which is deployed as a database driver, and that's what gets us into the critical path of data. That's what selectively will audit the data access and replace your plain text data with tokens. It also enforces policy. It's transparent to the application, and we pride ourselves on our ability to deliver the data at application speed. Below AlterDB, we have a separate product that we've run our DB product on top of called ALTR API, and it's kind of our storage engine. It's the data fragmentation and tokenization part of the stack. We fragment the data into very discrete, kind of self-describing chunks, and then we store them in a number of immutable ledgers. The result token has nothing to do with your data other than where your data is placed, and it's not even your data. It's a pointer to a chunk of data that we then reference and then deliver a reference token to your application. So at no point in the ALTR stack is there any map of any tokens to complete data, nor the location to the complete data. Is totally fragmented data, and this is available, or this is made possible through our intellectual property filing that we hold. There's a few advantages to each method. The DB method is deployed as a smart driver, like I said. It's JDBC or ODBC. There's very low code changes. The driver goes in, we're going to see here in a couple slides how easy it is. And really, it doesn't impact your business logic at all. Once the driver's in, you can configure it through a portal or an API, and it's deployable in a lot of modern and legacy patterns. The two kind of ends of the spectrum are freeze and wrap and microservices. We'll talk a little bit more about that in a couple later slides. On the API side, it's very simple, RESTful API. It's 4 or 6 endpoints. It's very simple. And it's designed for high throughput interactions with blockchain. We expose those operations through two kind of classifications of methods. There's a streaming API, which is used for blobs and just large kind of objects. And then there's a batch API, which you can think about as kind of more for JSON-sized objects that typically would carry a little structure. And then you can also leverage a little bit of concurrency out of that. And again, it's all deployable through a simple portal. You can get your API keys. You can start running fast. Right now would probably be a good time to start thinking about questions that you might have. You can submit those through the question portal on the side there. We're going to get to those at the end. Hopefully we'll have a really good Q&A segment. So this is really the root of it all, the ALTR chain vault. It is a blockchain that represents itself as an immutable data structure, and then we scale it horizontally as we fragment the data across the different immutable ledgers, and then we replicate it vertically here. So you can see we're able to gain super high availability of your data in the blockchain, but also security of the data because it's fragmented across multiple chains. Again, it works at application speed. Latency is completely negated through our stack as much as possible. It deploys flexibly. It's designed really to store anything. That's another piece of our intellectual property filing, is you can put any type of data in here, especially through the API. You can put PDFs, you can put structured JSON objects, you can put images if you want to, if you're doing any kind of document validation. This blockchain is built for flexibility. Our goal is to make sure that you are in charge, you the developer, you the builder are in charge of your problem domain. So the solution architecture, this is kind of a review before we dive into how we're going to install into your application. If you think about this, this is kind of any kind of client application here. Could be, any kind of 3-tier architecture. You've got your presentation layer, your business logic layer, and your data layer. Any of the normal patterns, the Java patterns, Spring Boot, Hibernate, whatever it is, we're just going to slice in right here this ALTR driver. And that's really going to sit right below your application, right before it talks to the database. This is your database here, and then we have one dependency here that gets installed. Once we do that, we intercept the request and response when it's in its most characterized form. Think about the type of data that's in the technology stack when you're initiating a query. It's pretty much everything that you would need to be able to make an assessment of whether or not you want to grant access to data. You can immutably log the query and all of the relevant information. Again, think of all that data. It'd be great to have that data. If you're ever in any kind of forensic situation or anything like that later on down the road, we capture a lot of that data. We verify policy. This is where we start to reach out to our SaaS offering here, which really is the broker of the policy. So we verify what you're trying to do with the holder of the policy, and then we restore data to its plain text form in the case of reads, right when the application is expecting it. And so your application is really not impacted at all, but the data follows a totally different path than what your application is thinking it's following. So this whole talk is kind of framed in the context of one sprint, right? We want to deliver a ton of value to the business in one sprint so that you, the builder, can get back to innovating. Couple of assumptions here before we kick off our sprint. You know, you've gone through the ALTR purchasing process, you've installed all of the dependencies. There's not very many. It's pretty easy, quick install. Most of the time it's inside of half of a day. You can probably do it before launch. So on day 0 to 3, we're going to enable ALTR Monitor into smart drivers, and then we'll find the sensitive data. We'll group it into what we call locks, which are logical groupings of fields. So you think about this as PII data, PHI data, or PCI data, HIPAA data, whatever it is that kind of applies to your business. You can kind of group them together. And the reason why you can group them together is to make it super easy for the business to deploy policy around that data. After that, days 3 through 5 here, we'll enable ALTR governance. We'll start to build that policy around the application's access to sensitive data. Moving on, we'll protect the sensitive data. We'll talk about how we take the data out of the database and replace it with the tokens. And then we'll apply that kind of previously built policy to the newly protected sensitive data. So it's not just we took the database out, or we took the data out of the database. It's we took the data out of the database, and now we're going to make sure that however it's being accessed is within the policy of the organization. Last thing we're going to do is we're going to demonstrate to the stakeholders of the business that you've significantly reduced your risk by implementing ALTR. And then we're going to show them that the sensitive data is no longer residing in your potentially insecure databases. So this is what a smart driver install means. I'm assuming that there's a healthy amount of developers watching this talk. You might be familiar with this kind of connection string. This is a normal connection string here. It's just everything vanilla about it. We're talking to MySQL. And then we add here just one little kind of delimiter that we want to use the ALTR driver, which we put onto the class path. And then your Java connection manager picks that up, and instead of you getting the normal MySQL driver, you're going to get the ALTR wrapped version of the same MySQL driver, actually. Once you've done that, you've really enabled ALTR Monitor, which is kind of the first kind of step in the product offering. We put the smart driver into the critical path. We have secure logging of all of that kind of really highly characterized information into the blockchain, and then we're able to kind of report on it. And also we have some SIAM integrations so that if there's other parts of the enterprise that need the data or that they can benefit from that data, you can actually propagate that information to them. I know that screenshots are a little corny on these things. I was told to keep it to a time limit. So unfortunately, if you I don't love seeing screenshots, but if you do want to see a live demo, you can reach out to us. We're happy to schedule one. I might even be the person to do it for you. This is what the monitor mode offering looks like. You can see your query, you can see everything about the query, and this is all done in our portal here. You can filter on it, you can export it to CSV so that you can do any kind of analysis on it that you might want to do, but really you're getting highly characterized information about what your application is doing. This is kind of an extended version of what one of those entities looks like. This is another screenshot from our portal. You get everything from the host that initiated the connection. So in this case, this is actually a Docker container. This is the instance of a Docker container. The user, the class path of the driver, the query, and then you also get to see how much data was returned and exactly what was returned. So not only are you seeing what the application asked for, you're seeing what it got back. And then you can also enable your application to report the actor information, what application user gives data. It's not good enough in most cases to be able to report this information and say, this Oracle service account consumed this data, because that's not really valuable to the enterprise, because that Oracle service account really represents the entire application in most cases. You can enable the application to report application user information. After we complete monitor, we start to look into govern. Like I said, we group the data into these logical groupings of fields called blocks, and then we can start to build policy around them. So you can see here that we can set access rate, time window, or IP address, types of rules. And then in terms of actions we can take when the policy is violated, we can block access entirely. We can what we call quicksand, which is where we will actually slow down the reading of the data on just one specific client, so that maybe you want to take time to evaluate what's going on. Maybe you even want to call security over to somebody's desk. This enables you to allow the business to keep going but still give yourself time to take action, and then generate an anomaly option here. This tells somebody, hey, I noticed this. Maybe you want to look at this, but there's no impact to the application at all. So in this scenario, the users are requesting the data through the application, which is using the driver. The data is still down here in the database, but we're enforcing the policy that's coming down to us from the ALTR product. This is really great for kind of credential breach kind of thing. If you have somebody who's scrolling through an application and that has a bunch of sensitive data every time they scroll, or the application showing a bunch of sensitive data every time they scroll, this is really designed to mitigate against that. The ALTR Protect offering is really the next level. From here, we will take the data, out of the database, we'll place it into the ALTR chain, and we replace it with these tokens. And that's where I was talking about when the driver encounters the token in the result set, it will go get the plain text data before your application expects it. So all of this happens in a way that's totally transparent to your application. Your application never knows that this is going on. But at the end of this, once you've enabled this in this database, the only thing that's relevant that you've classified as sensitive data is these tokens. One of the things we pride ourselves in is the kind of portability of the product. And I don't mean portability of the data. You can move the tokens around, of course, and everything, but I mean we really adopt to your specific use case, or we're able to deploy in your specific use case. We don't care where your application runs. We've seen the application deployed in kind of standard monolithic applications, just running as a service somewhere. Legacy applications, there's tons of those out there. If you have an internal cloud, that's okay too. And then we've seen the other end of the spectrum where, some of the companies adopting the latest standards, serverless, put into Docker containers. And then of course the API also is exposed to REST, which is pretty much ingestible by just about anything. I actually saw an AS400 do a REST call one time, and I was shocked. So the value to the stakeholders, what we're going to deliver to the stakeholders, is really what makes this super exciting. The digital truth about data access, the immutable audit trail, everything that you saw in that previous screenshot from what we call the query feed, that's in an immutable data store. Nobody can ever tamper with that. You can't go delete it. There's nothing there that can really be modified in any way. We're future-proofing policy and governance. If you think about this, our CTO has a great saying, and I like to echo it. The application developer used to build identity every single time they started a new application. And then Okta came along, and no longer did the developer ever have to write identity ever again. They just integrate with Okta. This is the same kind of a thing. You're not building the rules of the policy into your application anymore. In fact, the business can go in without the developer even knowing, and say, hey, customer service agents are only allowed to see 20 records per hour now instead of 50 records per hour. That took work off of your plate, the builder's plate, and that builder is hopefully now able to spend that time innovating. And then we secure the data. We say secure data means no data. It's the ultimate fail-safe. At the end, once you've identified all of your sensitive data, you've protected it with ALTR, there's nothing really left in that database. There's no cryptography or math that can turn those tokens back into plain text. And so, we like to say you could operate as if that database was available on the public internet without consequence. If you've really protected all of that sensitive data, there's nothing left to breach. So, you can see we're on day 8 to 10. I think it's pretty realistic to say that you could enable this solution well within that timeline. And so what we did, we talked about enabling monitor and smart drivers, grouping the data, enabling governance, building policy, protecting the data, applying a policy, and then we've shown stakeholders everything we've done, well within the 8 to 10 day timeline. So the key takeaways are security and compliance can serve themselves, low touch install, low cost of ownership and maintenance, focus on innovation, not risking compliance. I think from a builder perspective, that is so important. And then we're really enabling the business to adopt future privacy and compliance needs instantaneously without interrupting anybody. So I prepared a couple frequently asked questions. These are questions that get asked in the field absolutely all the time, so I figured we could address them head on. The first question that every single person, especially the builders, ask is, what about latency? And so, we've invested. I'll say all the things that a builder would expect me to say, and then I'll say, I'll continue to expand on that. We've invested from day zero on minimizing latency. It's something that's near and dear to our hearts. It would be foolish of us to say that, the applications can slow down and it would be okay in the name of security, because everybody views security convenience as a balancing act. But what I can say is, in the context of a page load and everything else that happens in an application to go get data, the user experience has never ever been degraded in any ALTR deployment. It's always been well within tolerances. So it's something that you can think about. I can't tell you that there's no latency in Protect, because we ultimately have to go get the data. But between the investments that we've made in really minimizing latency, and then also all of the other things happening in a page load or in an application screen load or anything like that, the user experience is pretty minimal. Also, you can get the monitor and govern functionality with almost zero latency cost. There's very little that has to happen there to enable that type of a functionality. So latency is something we're very conscious of, and we feel like the value far exceeds the minimal latency cost, and it's also the value far exceeds the minimal latency cost when you put into perspective of other solutions that provide the same amount of value. The next question we get, what about database compatibility? What if I have a DB2 instance, or what if I use Postgres, or even if I use some of the modified instances of Postgres? Today we have we have support for MySQL, Oracle, DB2, and Microsoft SQL. Postgres is right around the corner. In fact, it might be done by the time I finish this talk. It's right there. And then the last question that I get all the time is, what about NoSQL? The API was really built from the ground up for unstructured, semi-structured, arbitrarily structured, whatever structured data. And we've seen our API offering used in conjunction with NoSQL databases, and it's typically been a really good fit. So for anybody who's using those types of data stores, that's what I would recommend. I think we have time for a couple of additional questions. If you want to pop a few into the QA panel on the side there, I'm happy to take a few.
Yes, Chris. Audience, please, if you have questions, ask them in the questions panel, but there are 3 questions that are already in that the audience is curious about. So I'll start with the first one, and it reads, what criteria can set policy with? What is the recourse?
Right. So the criteria that you can set policy with is IP address, time window, and then also there's a couple of other things. If you characterize your queries with application user information, we can also build policy around that, and we can also build policy around the servers where the queries come from. It's a pretty flexible solution.
Perfect. Second question is, how do you prevent sensitive data that is captured in a query from being audited?
This is a great question. This is one of my favorites. If you were to go back and look at our query feed, so let me reframe the question actually. It is often the case, especially with a lot of older applications, that the query itself might contain sensitive information. You know, if you're in a patient health system and you're selecting by social security number, you know, select star from patients where SSN equals patient security number, that's in your query, but you don't want that to be a log to an immutable blockchain for forever. So our driver is actually able to go through, and as part of its parsing routine, it will go ahead and notify or notice that there's a literal string that would be a social security number or something like that inside of the query, and it will strip it out. And so what's left is kind of a skeleton of a query, and that's what gets audited.
Perfect. And the final question we have right now is, how is this different from any other proof of existence blockchain architecture?
Correct. So one of the problems with a lot of the public blockchains is the consensus algorithm is really built to solve different problems. The consensus algorithm is all about global consensus. And if you think about it, as the network gets bigger, it gets harder and harder to get consensus, which is why if you look at a lot of the blockchains that deal with currency and things like that, they have validation. It's really solving a different problem. So we kind of identified that as the pinch point for a lot of the public ledgers that were available at the time, and we changed our consensus algorithm to be focused around the integrity of the data, and that's how we're able to deliver the application speeds and the blockchain immutability at the same time.
Okay, someone would like to know, how does this stop an attack where credentials have been stolen or cracked?
So it's not about stopping the attack where credentials have been stolen or cracked. It's about saying, hey, those database credentials have been stolen or cracked. There's no data left to steal. There's nothing left in the database. So it's about the risk that's, you know, the risk that exists because of that database is now near zero, because we've taken the data and the only thing that's left in there is tokens. Similarly, you know, if they cracked application credentials or something, you know, further up the stack, you know, you would want to build policy so that that is identified very quickly. And once that happens, you know, we stop the breach. The application will not get any more data.
Okay, and if there are no more questions, I would like to thank Chris Struttmann for a great presentation. I would also like to thank ALTR for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Thank you and have a great day.
Thanks, everybody.